Morning everyone. Today I'll be going through the GCE O-level A-Math paper from this year. So I had a look at the paper and I realized that paper 1 was a bit more unconventional, whereas paper 2 was more standard, and my students also found it easier. So today we're going to go through paper 1. Today is Christmas Eve, so Merry Christmas and Happy Holidays. And I'll see whether I can get the paper 2 somewhere up next week. And I've already found out that my NS enlistment is not in January, so I should be able to find time to record the H2 math papers as well. But for now, let's start with the first question, which is quite normal, I think. We have a quadratic curve, 2x squared minus 8x plus 11. Complete the square, find the coordinates of the stationary point. Okay. 2x squared minus 8x plus 11. This is 2x squared minus 8x plus 8 plus 3, which is 2, factor out the 2, x squared minus 4x plus 4 plus 3, which is 2x minus 2 squared plus 3. So therefore A equals to 2, B equals to negative 2, and C equals to 3. What is the stationary point of the curve? Well, when we make the square part 0, we will get the coordinates as 2 and 3. The line y equals to 2x plus 3 intersects the curve at points A and B. Find the value of k so that AB is expressed as square root k. Okay, so we have 2x squared minus 8x plus 11 equals to 2x plus 3, is it? Yes, okay. So 2x squared minus 10x plus 8 equals to 0. 2, so this is x squared minus 5x plus 4, so that is x minus 1, x minus 4. X equals 1 or x equals 4. Then we have difference in roots is 3. Then k is equals to 3 squared, so you take the short distance. So basically what I'm doing here is that I'll have a curve, a quadratic curve like this, and a line. So, but the thing is I know that the line is gradient 2. So if this is 3, then this has to be 6, right? 3 squared plus 2 times 3 square. Then square root this to get the distance AB. So this is A and this is B. And you will get 45. Okay. So that is the value of k, because they ask you to express it in the form of square root k. So we don't need to simplify the cert here because this is what they wanted to leave us the answer as. Second question, okay, linear law. So the context is just dissolve in acid and exponential formula. Okay, plot ln m against t. So of course we need to draw the table of ln t first, ln m. 2.75 here. .49. 2.25. 2.00. 1.74. Okay, so let's see what we can do. So 1.5, let's call 1.5 here, and let's draw the line, axis here. This will be the t, and up here this will be ln m. Okay, so this is t equals to 1, 2, 3, 4, 5, and I'm going to intentionally leave a space here for the 0 so that I can get the vertical intercept. And we do not need to start the axis from 0, so I will do 1.5 here, and I'll go up to 2.0, 2.5, and 3.0. So you can see that I have divided each of the small squares into 0.05, so you can go up to half the smallest division. But in this case, you can see that the numbers they've given us are actually very nice, so we just need to round off. So 2.75 turns out to be right here in the middle. 2.49, well, you will round up to 2.5, so just put it here. 2.25, you will round it up to, well, yeah, it's right here. 2.00, you will put it here. And 1.74 round to 1.75, which is right here. So you get a very, very nice straight line, and it passes through 3.0 exactly. So your line will look something like that. Okay. Use your graph to estimate the amount of B present at the start of the reaction. So we have ln m is 3.0. Of course, you can just take e to the power of 3 and you will get m is 20.1, 3SF. Specifically 20.1 grams, I think. Yeah, okay. Use your graph to estimate the time taken to the nearest second when 50% of B has been dissolved. Okay, so for this we take ln 10.05, which is half of 20.1. Of course, you could just take 3 minus ln 2. That also works. You'll get 2.3076 5SF. And where is 2.30? This is closest to 2.30. So that will be here. So you look for this point and you see where it intersects the curve, the line. Where is the thing? It's here. Okay. Okay, so you can see that the intersection point is about here. The 8th box, which is 2.8. Okay, so t equals to 2.8, but this is in minutes, so you must change this to seconds. 0.8 seconds is 48 minutes, so 2 minutes and 48 seconds. Okay, yeah. So you can also actually write it as 168 seconds, I think, if you want to write it in all seconds, but I'll leave it at that. Okay. Question 3, okay, partial fractions. This is the case where you need to do long division. So they were actually a bit nice and told you that you need to do long division. By x squared. Then there's actually a 0x term here. Okay, so let's divide. Okay, so this is just 2x cubed. I'm pretty sure there's just a 2, right? So let me just put the 2 over here actually. 2x cubed and then plus 2x, or rather plus 4x, right? And you will get 5x squared minus 4x plus 6. So what you will get is 2 plus 5x squared minus 4x plus 6 divided by x cubed plus 2x. Okay. Now we will express this in partial fractions. So let 5x squared minus 4x plus 6, but x cubed plus 2x can actually be factorized into x and x squared plus 2. We're going to make this identical to a over x plus bx plus c divided by x squared plus 2, since this is the irreducible quadratic case. Then a, b, and c are real numbers to be determined. So there's many ways you can do it. You can do the comparing coefficients, you can do the simultaneous equations. So let's do the substitution method. 5x squared minus 4x plus 6. This is a of x squared plus 4 plus bx plus c x. Okay. So one of the ways we can solve is, let's start by letting x equals to 0, so to get rid of the bx plus c term. So you get 6 equals to 4a, which implies that a is, sorry, I think I did something. It's 2, not 4, sorry. Okay. A is 3. What else can we let x equals 2? Okay. So now we'll let x equals to 1. We just choose any nice numbers essentially. So you'll get 7 equals to 3 times 3 plus b plus c. So I know that b plus c is negative 2. And let's let x equals to negative 1 as well, which gives 15 equals to 3, again times 3. And then you get c minus b times minus 1, so you get plus b minus c. Okay? And therefore you have b plus c is negative 2, and b minus c is 6. So if you add them together, you get 2b equals to 4, so you get b equals to 2, and c equals to negative 4. Yeah. So therefore you get the partial fractions as 2 plus 3 over x plus 2x minus 4 divided by x squared plus 2. So far so good. A curve has this equation. Okay, this one's a bit weird. Points A and B lie on this curve. You have x coordinate of k and 2k. K is a constant 0 to 7. Find the range of values of k for which the y coordinate of B is greater than that of A. Okay, so this is a very interesting question, but let me show you how I approach it. So 14x minus x squared is actually a curve that passes through origin, and it's a quadratic set face. And in particular, this is 14, right? And this is 0. So the symmetry is actually at 7. Okay? So let's say I put k here, and I put 2k here. You can see that the thing is, the y coordinate of B is greater, right? But watch what happens once I put my... What I basically want is my k to be here and my 2k to be here. So that this is like the maximum. Once you go beyond this point, the 2k will be below the k, right? So I kind of want this to be symmetrical. So I let... So by symmetry, 3k less than 14. So k is... So therefore the range of values will be 0 less than k less than 14 over 3. I'm not sure how I would explain it in detail. I'll probably say that line of symmetry is x equals to 7. Then I want to have the average less than 7, basically, the x coordinates. That's how I would put it. And then you could also do 3k over 2 less than 7, which is the same thing. Okay? Explain why the gradient of the curve at A is always greater than at B. So if I just let y equals to 14x minus x squared, I can differentiate this. dy dx gives me 14 minus 2x. At k, you get 14 minus 2k. At 2k, you get 14 minus 4k, which is less than 14 minus 2k because k is greater than 0. Yeah, that's all. Binomial. Find the first 4 terms in this expansion. So that will be 2 to the power of 5 minus, if I choose 1, which is 5, 2 to the power of 4, ax over 2, plus 5 choose 2, which is 10, 2 power 3, ax over 2 square, and then the last term minus 5, because, no, 10, sorry, 5 choose 3 is also 10, 2 cube square, rather, ax over 2 cube. So you get 32. And then this is 5 times 8, which is minus 40 ax. plus 20 a square x square, then minus, so you divide by divide by 2 now, so you get 5 a cube x cube. Okay, so those are the first four terms. Given that there is no term in the x square in this expansion, find the positive constant a. So we compare coefficients. So we consider 2 plus 3x, and then we'll only consider the linear and quadratic term. The coefficient of x squared will be 40a squared minus 120a, which is 0. So I can factor out the 40a, a minus 3 equals 0. So a is 0, which is rejected because a is positive, or a is equals to 3. Hence find the coefficient of x cubed. Okay, coefficient of x cubed, I will consider 2 plus 3x, and then let's consider 20a square x square minus 5a cube x cube, which is 2 plus 3x. Substitute a equals to 3, so you get 180x square minus 135 x cube. The coefficient of x cube equals to 540 minus 270, which is 270. Okay? A curve is such that the 2y dx squared is 2e minus x plus 62x. If it intersect the y-axis at p05, the gradient of 3 at that point, find the equation of the curve. So dy dx is integral of 2e minus x plus 6e 2x dx, which is minus 2e minus x plus 3e 2x if you apply the exponential integration rules, plus c1. c1 is some constant. I know that at the point when x equals to 0, okay, this is e to the power of 0 is negative, e to the power of 0 is 1, so you get 1 plus c1 equals to 3, so therefore c1 equals to 2. So now we will find y, which is the integral of minus 2e minus x plus 3e 2x plus 2 dx, which is 2 positive 2 e negative x plus 3 over 2 e to the power of 2x plus 2x plus c2. Okay? When x equals to 0, what is y? Well, you'll get 7 over 2 plus c2, and this is 5, and c2 is therefore 3 over 2. So therefore your equation of curve is y equals to 2e power negative x plus 3 over 2 e 2x plus 2x plus 3 over 2. I actually think it's a pretty simple question. Question 7, geometry proof. The diagram shows a circle, center O, diameter is PQ, PT is tangent to the circle, R lies on the circle, tangent at R meets PT at S. Angle RPS is X, proof in either order that RST is 2X, okay. So, if this is X, note that RS and PS are both tangents, so this is also X, right? Angle RSP equals to, X, because of, actually I should specifically say it is also equals to RPS, which is X, because angles, because well, there's actually there's technically two reasons. Oops, what did you do there, Kami? There's technically two reasons. First, tangents from external point are equal. So PS equals RS. Then you use base angle of isosceles triangle. Okay? And therefore, angle RST is 2x because sum of two exterior angles, two interior angles, equals exterior angle. Okay? Prove that triangle RST is isosceles. That should be quite simple. This is a right angle because right angle is a semicircle, right? Is there a semicircle? Oh, yeah. The semicircle is actually PRQ. So angle PRQ is 90 degrees, right angle in a semicircle. And therefore angle PRT is also 90 degrees, adjacent angles on straight line. Okay, so this is x, this is 90 degrees minus x, so SRT equals to 90 degrees minus x, there's no reason for this, and PTR or STR equals 90 degrees minus x, and this one has the reason that sum of angles in a triangle is 180 degrees, which is angle SRT. So base angles of isosceles triangle RST is isosceles. Okay, cool. And I think there's actually an interesting thing here. S is the midpoint of PT as well. They did not ask you to prove it, but actually S is the midpoint of PT. And I will let you guys in the comments let me know why that would be the case. Okay, just a little bit of a bonus question. Okay, question 8. We have the curve y equals to 3 root x and the line for y equals 3x plus k. In the case where k is 9, find the coordinates of p and q. So we have 3 root x equals to 3x plus 9 divided by 4. We can actually factor out 3 over 4 here. X plus 3. Squaring both sides gives us 9x equals to 9 over 16. X squared plus 6x plus 9. We can get rid of that 9 over 16 and multiply by 16 over 9 on both sides, which actually gives us 16x on the left hand side. So if I rearrange everything, I will get x squared minus 10x plus 9 equals to 0. Factoring this, x minus 1, x minus 9 is very nice. So you get x equals to 1 or x equals to 9. If I put in 1, I'll get y equals to 3 because 3 root 1 is 3. Or if you put in x equals to 9, you get y is 3 root 9, which is also 9. Okay, so P is 1 and 3, Q is 9 and 9. Okay, in the case where the line is tangent, find the value of K. There's a few possible approaches to this. There's the calculus approach and there's an algebraic approach. I'll do the algebraic approach. So let's let 3 root x equals to 3x plus k divided by 4. If I multiply by 4 on both sides, then square 144x equals to 9x squared plus 6kx plus k squared. So I need the discriminant of the quadratic equation. The discriminant of the quadratic equation is 6k minus 144, if you can see, square, minus 4 times 9 times k square. Okay, so this is, and I can actually factor out the 6 here, and I'll get 36. Then k minus 24, I'll square this. K squared minus 48k plus 576 minus 36k squared, which is 576, or rather 36. 576 minus 48k, which is 0. So the value of k that I need is 576 divided by 48. which is 12. Okay? Yeah. So that will be the value of k, which gives you the tangent. There's probably a calculus method to this as well. I'll let you try it. The equation of a curve is x cubed minus ax squared plus bx plus 4. Show that if y is increasing, then a squared is less than 3b. This feels quite similar to like the Cardano criterion. dy dx equals to 3x squared minus 2ax plus b. So if y is always increasing, then let dy dx greater than 0 for all the real numbers, which requires the discriminant of the equation 3x squared minus 2ax plus b equals to 0 to be less than 0, right? Because you want to ensure that because the coefficient of x squared is positive here, if the discriminant is less than 0, it will never cut the x-axis, it will always be above it. So it will always be increasing, right? Okay, so we need 4a squared minus 3b to be less than 0, which is 4a squared less than 12b. Dividing by 4 on both sides gives us a squared equals less than 3b. Okay, so that's it. If a is 8 and b is 10, find the x coordinate of each of the 3 points where the curve intersects the x-axis. So basically we are solving the equation x cubed minus 8x squared plus 10x plus 4, is it? Yes, equals to 0. So this is the standard solving of any cubic equation. Okay. So of course the first step is trial and error one linear factor, right? So let fx be x cubed minus 8x squared plus 10x plus 4. Then if you do by trial and error, you'll actually find that f2 is 8 minus 8 times 4 plus 10 times 2 plus 4, which is 32, 20. Okay, so that is 0. Okay, so x minus 2 is a factor. And then you have f of x must be x minus 2. Comparing coefficients, you will get x squared plus ax plus minus 2 by inspection of the coefficients of x squared in the constant term. Then if you compare coefficient of x, or x squared also can, you'll get minus 2 you'll get that this is equals to 10. And therefore, what is A? A will be minus 6, is it? Negative 6. Let fx equals to 0, then x equals 2, or x squared minus 6x plus 2 equals to 0. Or minus 2 rather, sorry. X minus 3 square is this x squared minus 6x plus 9 minus 11. So this is 11. So x is 3 plus minus root 11. Those are the other two roots. Although the question did not actually say exact, so I think if you put it as 3 as f, they will accept. But I think since it's quite a nice cert form, you can leave it as that as well. Find the amplitude and period of the following functions. Okay, this is gonna be a joke, right? The amplitude is 2, and the period is 2 pi. The period, what's the amplitude of this? Don't be fooled by the negative sign, don't be fooled by the constant term. Just take the absolute value of the coefficient of the cosine or sine function, which is 4, and the period here will be pi. Sketch on this diagram the same curves. Okay. So plan your curves a little bit before you sketch. What is the maximum value of this? 7, right? Maximum value is 7. The minimum value is -1. And this one is -2 and 2. So just a bit of planning before we sketch the curves. Goes a long way. Let me put the axis a bit lower. Okay. -2, 2, 7. And this is the y-axis. Okay. So sine starts from the origin. And let's call 2 pi over here. In that case, pi is over here somewhere. This is pi over 2. This is pi, 3 pi over 2. Okay, so sine will have one single cycle, right? So go up to pi over 2. Something like that. Comes back down to pi. Comes back down here. And it goes back up top. Something like that. Okay? Then 3 minus 4 cosine 2x. So cosine normally starts at its highest point, so 4. 3 minus 4 is -1, so -1 is over here, so it starts here. Normally it starts decreasing, but here it's negative, so it will actually increase instead. And it will head up to its maximum point. At pi over 2, it will actually head to its central point, which is like 3, right? So if you want, you can put a 3 here, so that you can give yourself a guide as to where the cosine should go. Actually, no, it will be concave upwards, right? No. Pi over 2 will be where its maximum point is. Sorry. And therefore, you need to make it go up and then, yeah. So make it go concave upwards very quickly until about pi over 4, where it will be at 3. Try to put it in the center. And then stretch it upwards a bit. Oops. Oh, Kami is a bit weird. Just make it go up until about pi over 4. And then finish off the curve from there. So you get something like that. Okay? Then same thing, break it back down until you get about 3 pi over 4. And then make it at 3. Then come back down to pi, where you'll be back down to -1. Okay? And then you just repeat the cycle. A bit difficult to get back down here. Yeah, something like that, okay? So this is y equals to 3 minus 4 cosine 2x. And the graph on the bottom is the y equals to 2 sine x. Okay? Yeah, so it looks something like that. Just make sure you get the max and mins. Okay. And they only gave 3 marks this time, so it shows that they're actually stepping up their game for trigonographs a bit. The triangle ABC is such that A is 4, 2, B is 10, 2, and C is PQ. The area of triangle ABC is 15, AC is square root 89. Okay, so if you want, you can draw the diagram. So 4, 2, where is 4, 2? So 4, 2 is somewhere here, and 10, 2 is somewhere here. C is going to lie above A and B, because the area of the triangle requires that C is not on the same y coordinate. You'll see that the line is actually parallel to the y-axis, so you'll get A, B, this is 4, this is 10. This is actually parallel to the x-axis, right? Okay, so therefore your C must be somewhere here. So no matter what is the exact x-coordinate of C doesn't actually matter because we have a perpendicular height already, which is y. So half times base times height, half times 10 minus 4 times q minus 2 equals to 15. So you get q minus 2 equals to 5. We know q is greater than 2, so we can just write this as a deduction immediately, and therefore q is equals to 7. Okay. Find the possible values of p. So of course AC squared is 89. So what I need to do is find the equation of a circle. So I'll use distance formula rather. So if I use p minus 4 square plus, okay, we already know 7 is here, minus 2 square equals to 89. So p minus 4 square. So this is 89 minus 25, which is 64. So therefore p is 4 plus minus 8. P equals to -4 or P equals to 12. That's it. Don't know why they gave 4 marks. So I feel like some of the standard questions, they are very, very generous, whereas they also ask a lot of unconventional questions. Okay. This is probably the most difficult question because you need to understand the context. It's a kinematics context. My students told me that they were very confused by the question, and I saw it was a physics context. I know that my students were biochem, they didn't take physics, so this was a bit of a disadvantage. I feel that Cambridge was a little bit unfair with the context, expecting them to know what is an oscillation, when the fact is that not enough students actually take physics. So it's very possible that they may totally not be able to do the question, right? But I think it's a learning experience for everyone as well. So let's have a look at this. It's kinematics. We have a computer screen that's 120 cm wide. The dot oscillates in a straight line between A and B. I did copy the question verbatim, by the way, and it never said which is the positive direction. AB is parallel to the base. Displacement is modeled by A sine nt. T is the time in seconds. A and n are constants. The time for one oscillation is 6 seconds. Y is A 60 and show that n is pi over 3. Well, the displacement is, this is the amplitude, right? And we can clearly see that there are two amplitudes, and it's 120. So two amplitudes, which is 2a, is 120. So therefore a is 60. And n is pi over 3. Okay. So we know that the period of the standard sine function is 2 pi. So I know that the period, so the period of the oscillation is actually 2 pi divided by n, right? Which is 6, and therefore we can solve for n. N divided by 2 pi is 1 over 6. So you get n equals to pi over 3. Okay? Find an expression for the velocity of the dot at time t. Deduce the maximum speed. Okay? So v equals to dx dt, which is 20 pi, because you need to take 60, then you take out the pi over 3, cosine pi over 3t. Max speed is just 20 pi cm per second, which is when t is like 3 over pi. It's one of the possible values. Find the magnitude of the acceleration of the dot when it is at a. Okay, so a is dv dt. If you differentiate this, you'll get minus 20 pi square over 3 sine pi over 3t. So because they're asking for the magnitude of the acceleration, it doesn't matter whether t is plus minus, whether sine is plus minus 1. So at a, magnitude acceleration. Once again, the positive or negative direction of displacement doesn't matter because we're taking the magnitude. So minus 20 pi square over 3 times 1, because that's the maximum or minimum value of the sine function, which is 20 pi square over 3 cm square per second. Okay. I know pi square is very weird, but yeah, that's the answer. So it's all about understanding the context if you want to be able to answer the question. Once again, for non-physics students, I feel that's a little bit unfair, but in the end, I think the rest of the questions are quite manageable. And this is the last question. We have this curve here. Explain why the curve does not have a stationary point. Okay, so of course we can find dy dx. We can express 4x plus 2 in this form. And in fact, I would actually do this first. I will do this part first because it makes things easier. So I'm going to show you two ways to find the derivative. I can actually write this as 4x plus 4 divided by x plus 1 minus 2 divided by x plus 1. Then I factor out the 4, I will get 4 minus 2 over x plus 1. It's very easy to deduce from here that dy dx is just 2 over x plus 1 square, right? You could of course do it the traditional way also. So let's do it that way. You will get x plus 1, 4, minus 4x plus 2, and 1, divided by x plus 1 square. You will get 4x plus 4 minus 4x plus 2, which is indeed 2 over x plus 1 square. So yeah, you can verify both ways. So dy dx is not 0 for x, all real x, therefore no stationary point, right? The point P lies on the curve. The gradient at P is half. The normal to the curve at P meets the x-axis at A and the y-axis at B. Okay? So dy dx equals to half, which basically means that x plus 1 square equals to 4. Then we know that x is greater than negative 1. So therefore the only possibility is x is 1 itself, right? We can find the equation of the normal because that is what AB is. The gradient normal is negative 2 if you take negative reciprocal. When x equals to 1, what is y? It is actually just 3, right? So therefore equation normal, y minus y1 equals to m x minus x1. Y is negative 2x plus 5. Okay? You can deduce the coordinates of A and B. A is at the x-axis, so therefore it is 5 over 2 and 0. And B is 0 and 5. And from here, area of triangle AOB is half times 5 times 5 over 2, which is 25 over 4 unit square. The line y equals to c does not intersect the curve. I expressed it in this form already. Just now I showed you how. Explain why c is greater than 4. From diagram, when c is less than 4, there's a point on the curve. Okay? Or when y less than 4 rather. At y equals to 4 and beyond, there's no point on the curve, right? The curve can never reach that point. This is what we call the asymptotic behavior. So let me put this somewhere else. When y is greater than 4, asymptotic behavior 4x plus 2, x plus 1 tends to 4 minus, but never reaches 4. So therefore the line y equals 4 will not intersect. Okay? Yeah. So I think that's all. Overall, I think it's a quite manageable paper in the end. Even though there was the very weird kinematics question and a few slightly unconventional questions, I think that overall the paper is manageable. And besides, the paper 2, which I will probably do sometime later next week, is also very manageable, and my students told me it was easier than paper 1. So I'll get that up later. And as for now, once again, today is Christmas Eve, so Merry Christmas, Happy Holidays, enjoy yourselves, guys, before we get back to the study grind for those of us who are still in school. And yeah, I'll see you guys next time. Take care.